We have this LC oscillation circuit with the voltage amplitude across capacitor to be Vm. We need to find at any given time t, find the relation between current and voltage across the capacitor. So current in the circuit and voltage across the capacitor. Solve this problem using Ohm's law and the energy conservation law. So by Ohm's law, we will just use the KVL. So let's say here the charge is plus Q, here is minus Q, and I current is flowing through the coil. So I have taken the direction of I to be this, so I is simply dq by dt. So KVL in this loop gives minus Q by C minus LdI by dt is equal to 0. So minus Q by C minus LdI by dt is equal to 0. And I will be dq by dt. So we just want to get one variable Q. So we get our equation d2q by dt square plus 1 by LCQ is equal to 0. So this is the equation of SHM. So charge will be varying in a harmonic fashion, and the frequency of those oscillations will be root 1 by LC. Therefore, our equation of SHM, equation of harmonic variation of charge will be Q is equal to Q naught cos omega t plus phi. So we are taking a general phi because they have not given the initial condition. So we need to introduce voltage and current because we need to find the relation between them. And what we have is Q. So to introduce voltage, Q is related to voltage as CV. So Q naught will be C into V maximum. So this will give V to be Vm cos omega t plus phi. So we have got V. Now we need I. So we just differentiate this equation, and we get I is equal to minus CVm omega sin omega t plus phi. So we need a relation between voltage and current. So let's get rid of t and phi. So we'll just square and add them, and we'll get I by c omega whole square plus v square is equal to Vm square. Omega from this equation, we know it is 1 by root LC. So we put that here, and our relation becomes Li square plus Cv square is equal to Cvm square. So this is with the KVL, that is Ohm's law. Now let's arrive at the same solution by energy conservation. So we know energy stored in the capacitor is half Cv square and energy stored in the inductor is half Li square. So sum of that should be constant because there is no resistance, so power is not lost. Now we don't know the value of constant, so for that we are given what is the maximum voltage across the capacitor. So let's introduce that condition. So when voltage across capacitor is maximum, that means dV by dt is 0 and V is Q by C. So that means d by dt of Q by C is equal to 0, or 1 by C dQ by dt is equal to 0, or current is 0. So when voltage across capacitor is maximum, then current is 0. So we put those values here. So half CVm square. So when voltage is maximum, current is 0. So we got the value of constant, and that is half CVm square. So the same result we got here. All right.